back to Ms. Nicole Tutoring. So now we're going to be talking about tangents to a curve. So what does that even mean, right? So let's recall from previous lectures that a tangent line has the form of y is equal to mx plus b, right? It's a linear standard form, which we've seen before in like grade 9, 10. Or also the form of y2 minus y1 is equal to m times x2 minus x1. Remember that we have these points, right? These particular point, and the slope is m. In our case, we're going to be labeling it as y minus y1 is equal to f prime at x1 times x minus x1. So the only thing that changed really is m, right? The slope. Now recall also that the derivative of a function, at a point, right? Derivative of a function at a point, some particular x1, is the slope of the tangent line at that point. Remember that the tangent line has this form. So the slope of the tangent line is going to be the derivative of the function at that point. Okay, we also want to remember that a horizontal tangent line has the slope of 0. So f prime at x1, the slope from here, is equal to 0, or is undefined, which we're going to talk about in a sec. So let's just see what that looks like visually. So say we have this sort of function, right, in purple, f at x, and we have a particular point in time c, and f at c, which is just the y value, right? This is just a side comment as well. This is a minimum point, right? F at c is the smallest possible y value this function could ever get, because it could get really, really high on the y-axis, right? It could get like to a positive infinity, to like positive 1,000,000, 2,532, whatever it is, right? Versus over here we have some sort of minimum value, which is the smallest possible value this function can get. So if we're talking about, again, tangents, at this particular point in time at c, if we were to draw a line passing through that point, the one in red right now, okay, it passes through that point once, so we see that it is a flat line. Now, like if we completely ignore this graph, like so, we just see a flat line, a horizontal line on this graph. And we know that to label a horizontal line, it's usually going to be y is equal to something, some sort of number, right? Y is equal to b, for example. So it has a slope of 0. There's no m value here. So let me just bring back that function for us. Okay? So that's why this is important. So now if I were to take f at c and I were to find the derivative at that value, I actually get the slope of the tangent line at c, right? The slope of this line at c. Okay, so let's do a couple practice problems along with this because this is a short tutorial. So let's start with question 1. If suppose I want to know the tangent to the curve of f at x is equal to x cubed minus 3x squared at a particular point, 1, -2, for example. Okay, so x cubed minus 3x squared at the point 1, -2, so find the tangent to the curve. So let me write down the steps for us. So step 1, find the derivative. Okay, let's do that. F prime at x is equal to 3x squared minus 6x. Okay, so now that we have the derivative function, right, 3x squared minus 6x, we now need to see, okay, well, we're looking at this particular point. So we need to plug in only the x value, right? So our step 2 is going to be plug in x of the particular point, right? So, because we want to know what the slope of the tangent line is. So f prime at 1 is equal to 3 minus 6, which is equal to -3. What this just gave us is the slope of the tangent line. So now that we know the slope of the tangent line, our step 3 is going to be create an equation for the tangent line. So we can do this by listing everything we know. Well, we know the tangent line has a slope of -3, right? That's equal to f prime at 1, which we just figured out. And we also know that it has to pass through the point 1, -2. And we've learned this in advanced functions classes, right? So now we just have these two things and we want to come up with an equation. So there's two ways you could do this. You could solve it using this, mx plus b, which I'll show you how to do. Or a secondary way, you could do y minus y1 is equal to mx minus x1, right? So many people have different preferences. It does not really matter. Let's give both of them a go. So first, let's plug in to the first situation here. We have -2 is equal to -3 times x, which is 1, plus b. And solving for this, we end up with an equation that says y is equal to -3x plus 1. Because from here, we solve and we get b is equal to 1, right? So we just plug it all back in. In the second scenario, we're plugging things in again. We get y minus y1, which is -2, so plus 2. Two negatives make a positive. -3 is the slope. X minus x1, which is 1. So again, we're going to move things around. We get -3x plus 3 minus 2, or -3x plus 1, which is the exact same thing that we got here. So we get the exact same answer no matter what way we solve for it. Okay? Let's try another example. At this time, once I write it down, I'd suggest for you to try it on your own and see how you do. This one involves a little bit of implicit differentiation. At x is equal to 0. Recall, again, we're looking for find the equation of the tangent line at this particular point. So it's at x is equal to 0. Okay, so step 1, we want to differentiate. Right? We want to know what the derivative is. So find derivative. If you're not too familiar with implicit differentiation, check out my other videos. So we start. We have the product rule at first. We have 2xy plus x squared dy over dx minus 1 is equal to 3y squared times dy over dx minus 0. And now we need to keep solving. So we're going to move everything with dy dx onto one side so we can eliminate for it. So I'm going to choose this side here, dy over dx, subtracting 3y squared dy over dx on both sides. Okay, that's subtracting this from both sides. And I'm going to add 1 to both sides, so it cancels out on the left side. And I'm going to subtract 2xy, so it cancels out on the left side as well. So we have 1 minus 2xy. Okay, we're going to factor out dy over dx. X squared minus 3y squared is what we're left over with, is equal to 1 minus 2xy. So now we're dividing both sides by this value. So it cancels out on the left-hand side. We get dy over dx is equal to 1 minus 2xy all over x squared minus 3y squared. So now we found the derivative. Great. Well, what's our second step? Our second step is to plug in the x value. Now, usually we would simply plug in the x, right? X is equal to 0. But in this case, we also have a y value. So we're not going to be able to figure out what the derivative is equal to unless we know what the y value is. Remember that this is just f prime at x. So let's figure out the y value using our original equation here, right? This says that y is equal to 2 when x is equal to 0. So a little work here, 0 for x's, right? We have 0, this cancels out, and then we have y cubed is equal to 8. Take the cubic root on both sides, you get y is equal to 2. Okay? So we're going to plug in those 2 points, and y is equal to 2 into our function, f prime at x, or dy over dx is equal to 1 minus 2 times 0 times 2, x and y, x squared, so 0 squared minus 3 times 2 squared, and you end up getting -1 over 12. So what we just figured out is that the slope of the tangent line is equal to -1 over 12. And now you do the exact same steps as before by finding the equation. Right? So now you're finding the equation of the tangent. So let's plug things in. Y minus 2 is equal to -1 over 12 times x minus 0. And the equation you come up with is then 12y plus x is equal to 24. So this is the equation of the tangent line at when x is equal to 0 for this function.